So transfer statements in Python are mostly used to transfer the control from one part of the program to another. Now in Python, there are three types of transfer statements: break statement, continue statement, and pass statement. We usually require whenever we want to terminate the loop. Now the control of the flow is going to jump immediately the statement which is present after the loop whenever I am using the break. Now let's see one example. Let's say we have taken a list like fruit having certain items, and we have taken a for loop here, and this for fruit in this particular list fruits, it is going to take one of the item at once. Now inside this we have added one condition that if the fruit is cherry, I mean by the time the fruit reaches this third item, that is cherry, I flash a message like I found this cherry, and then this break is going to execute, as a result of which this entire loop is going to terminate and we will come out of the loop, and the very immediate line that we have written here is loop ended. So now when we are going to run this for the first time, because the fruit is going to carry apple, so this condition is not satisfied. Hence we get the message checking followed by the fruit. What is that? Apple. Now for the second iteration where the fruit is banana, once again this condition fails. Hence we are able to get this checking fruit, that is checking banana. But for the third time when the fruit reaches this cherry, now this condition is satisfied. Hence I get this message like found. What is the fruit? Cherry. Breaking out of the loop, this message. And then this break statement is going to end the loop completely and is going to come out of the loop. Now after the loop is ended, we have kept a message here, loop ended. That is what we are going to get here. So here if we are not using this break, anyway this fruit is going to go up to this date as well as this elderberry. But because we have used break here, in between it is stopping the loop and is coming out of the loop. So let's see one more example where I'm trying to make use of the break statement. So the program is you have to input a number and you have to check whether the number is prime or not. So we understand a prime number is a number which is divisible by 1 and itself. So what we have done here, we initially ask the user to supply a number which need to be tested as it is prime or not. Now here we have taken a variable, say flag, which is set to 0 initially. Now this for loop is going to start with the range. What is the range is 2, num, that is float division by 2 plus 1. So let's say we have taken the number as 7. So the num is holding 7. Now this range is going to produce 2, 7 by 2 plus 1. That is 7 by 2 is your 3. 3 plus 1, that is maximum 4. So when I'm applying range on 2, 4, which means obviously this is the end value. So end value minus 1 means it is going to go up to 3. So I value will be 2, I value will be 3. Now when I'm getting inside this for loop, we have a condition here, num percentile I equal to 0, because num is 7 and the I value for the first time is going to be 2. So 7 percentile 2 equal to 0 is going to be false. As a result, these statements will not execute. Now in the next iteration, the I value is going to be 4. Now when I check 7 percentile 4, it is once again not equal to 0. Hence this will not execute. Now because we have come to the end of this for loop, now when I come out of the for loop, I am just checking whether the flag value that I have started initially as 0, is it still 0? Yes, it is, because these statements are never executed. Hence flag still holds the value 0. Hence this condition gets satisfied and we say that 7 is a prime number. Now let's say we have taken one more number 21. Now when I'm taking 21, so now let us see, once again the flag is set to 0. Now this for loop I in range of 2 comma 21 by 2, that is 21 by 2 is nothing but we'll get 10, 10 plus 1, that is 11. So the range is 2 comma 11, means it is going to start from 2 go up to 10. Now when I check this first time, num percentile I, what is num value? 21. Percentile I value begins with 2. So num percentile I, that is 21 percentile 2 is not equal to 0. Hence this two statements will not execute. Now for the next iteration, the I value becoming 3. Now when I check this 21 percentile 3, so 21 when divided by 3, the remainder is 0. So 0 equal to 0, this condition is satisfied. And because this condition is satisfied, so these two statements will execute. As a result, what is the first line? Flag becomes 1. Flag was earlier 0. Now the flag has been updated to 1. Now immediately there is a statement called break. And we know that break is going to terminate the loop completely. And now we are going to come out of this loop where we have written this if else, where I'm checking whether flag value, what is the flag value presently? Updated as 1. So 1 equal to 0 is false. As a result, the else block will execute where it is displaying the message like number is not prime. Now, if I do not use this break here, this range function which is producing 2, 3, 4 up to 10, so those many iterations will be worked on it, and then finally we will be able to tell that yes, the number is not a prime. But now break is helping me out because I'm not worried about how many divisors do I have for 21. I just wanted to check, is there any number available apart from 1 and itself through which this number is divisible. So because I found the very first number here is 3, hence we are terminating the loop because we have got exactly what we are looking for. So that is how the break has some significant role to be played in this particular program. So the next transfer statement is your continue statement. And we can use this continue statement to skip the current iteration and continue with the next. Now let's understand. Say we have a requirement of printing the numbers from 1 to 5, but I do not want to print 3. So what we have done here, we have taken a for loop here. So 1, 6 means I'm going to start with 1, the range function, and it will give me up to 5. Now, inside this loop, what I'm doing is I'm checking a condition. By the time I is equal to 3, I'm executing this continue. So when I value is 1, this condition fails. Hence, what I'm able to get is printing the I value. What is that? 1. Now, next time the I value is 2. Once again, this is failing. So I'll be able to print the I value, that is 2. Now, for the third time when the I value is 3, so 3 equal to 3 is true. As a result, continue statement will execute. And what this will do, this print statement will not be executed now. It will be skipped from execution. And it takes me to the next iteration where the I value becomes 4. So now 4 equal to 3 is false. Hence, continue will not execute. As a result, print I will execute. So I am going to get 4. Next time, I value is 5. This condition is again failing. So I am be getting 5 here. Now we have come to the end of this range function. Hence, my for loop is going to produce 1, 2, 4 and 5. And what I have skipped here is 3. And that is possible because we have used the continue here. And after this for loop is ended, obviously the next statement will continue. That is 1, 2, 4, 5 and loop is ended. Okay. Now the third transfer statement is your pass. Though it is not a transfer statement exactly, but most often the role of your pass statement is, it is a keyword that we use in Python to define some empty statement, and it does nothing. Now in our programming, syntactically there is nothing like empty block. You cannot write empty block. Okay. So whenever you want to specify an empty block which do not do anything, so we should be using this pass keyword. For example, here let's say we have taken if x equal to 10, I don't want to do anything. Now if you simply write if x equal to 10 colon and leaves nothing you write here, this will lead to an syntax error. But in place of this blank, if I'm writing pass, I mean if x equal to 10 colon then pass, then this is valid. So here the pass meaning is that even if this condition is true, nothing is going to happen. Similarly, let's say here I am taking the help of a function. Suppose I am defining a function, which we will discuss later. Now, function definition normally holds certain statements. But suppose I want to define a function where there are no statements. So then again, I cannot just write def1 colon and leave like this, because it is going to give syntax error. Now, if I'm going to write the same with the addition of this pass, this is absolutely valid. So overall, the pass statement is required whenever you want to generate an empty block. Maybe attach it to an if, maybe attach it to an else, maybe attach it to a function, or maybe it is attached to a class.